Today we're going to talk about rotations. Rotation is another one of the transformations in this chapter. We've talked about translations and reflections so far. The rotations do the same thing that those two transformations do, in that it doesn't change the size or the shape of our image as we move it. The rotation, though, has several different things about them that the other two don't have to deal with. So a rotation is when a figure is rotated around a point called the center of rotation. So here in the diagram, we've taken this shape and we have turned it around this center. And so there's a couple of things that we have to talk about. There's the angle of rotation. How far are you turning it? So, and then there's also the direction of how are we turning it. Are we turning it to the right? Or are we turning it to the left? So there's two words that come into play with which way are we turning it. The first one is clockwise. So if you think about the clock up on the wall at school, the big dial hand ones, it goes in this direction, which is the clockwise direction. So if I see I'm turning the shape to the right, that's the same way that the second hand would turn on a clock. If I'm counterclockwise, that means I'm going against the clock or I'm turning it to the left. So those are two things to be on the lookout for. Clockwise means to the right. Counterclockwise means it's turning to the left. And then we have to look at, well, how far am I turning? So depending on how far I'm turning will depend on looking again at that same clock up on the wall. So if I was to go 90 degrees, for example, on the clock up on the wall, it would be at 12 to the 3. This is a 90-degree turn. It makes a 90-degree angle. That would be like one turn. If I was going 180, I would then be coming all the way down to the 6. There's 180 degrees. And if I was stopping again at the 9 here, and again, this is all coming from the 12, this from here all the way around to here would be 270 degrees, because remember, a full circle is 360 degrees. So rotations have several things we want to be on the lookout for. We need to look at how are we turning left or right, clockwise or counterclockwise. We have to know how far we're turning. So a 90-degree turn, is it a 180-degree turn? Is it a 270-degree turn? And sometimes you can kind of have some that equal the same thing. So for example, if I was to do, let me just get this, if I was to do a 90-degree turn from 12 to the 3, which would be clockwise, that's the same thing as if I was to go counterclockwise 270 degrees. Okay, so let me say that one more time. If I went clockwise 90 to get from 12 to 3, I also could go from 12 to 3 the opposite direction, which is counterclockwise 270 degrees. So sometimes you're going to see some that are greater than the 180, and it's because you're going a little bit further past. Obviously 360 is as far as it would go. Now there's some different angles that you will get to in your geometry courses. We're only going to focus on the 90, 180, 270, counterclockwise and clockwise. So it's difficult to show this on a video. We will be working on some stuff in class to try to help this a little bit. But what we're trying to do here is recognize how is this puzzle piece rotating 270 clockwise. So again, think that's from the 12 on the clock all the way around to the 9 on the clock. So there's kind of 3 turns that are happening. And we're going around point P. So I got to kind of think, how am I going to go around point P with this puzzle piece and see what it's going to look like? And we're going to talk about this in class. What you would do is you want to think turning your paper. Your paper is a 8 by 11 kind of size paper. It's a rectangle. If I turn that paper 90 degrees, I'm going to turn it from tall to then longer and shorter, and then again tall to be at 180 upside down, and then one more turn. So if I make 3 turns of my paper, I will kind of see what it's going to look like. And so if I was to make 3 turns of this paper, what I'm going to see is that my picture ends up looking like this right here, letter C. And again, I think the easiest way is for me to kind of just hold off for now, and we'll go through it when we get into class on this. This next thing where it talks about how you know just by looking at the coordinates. We talked about this with translations and reflections. To be honest, I feel like it's very confusing. If you are someone that can kind of understand this and use this, that's great. There's an awful lot of other things that can be happening that can very easily confuse us. But basically what this is saying is if I'm going to do a 90-degree turn, and notice that it says counterclockwise up here, that our XY coordinates become reversed, not XY anymore, they're YX, and also the Y is now the opposite sign of what it was. So again, to me, these are great if you can understand what that means and then remember them whenever you see the situations that you see over here. I'm not going to focus on these too much because I think that it's just easier to actually do the physical turn. But that's up to you if you want to focus on those a little bit. What is important is I want you to see down here, in a rotation, the original figure and its image are identical, which means the original is whatever size and shape it is. The image is that exact same size and shape. So doing a rotation does not make the shape change in any way, except that it's going to have a different look because it's been turned. So let's do the first one. And again, we're going to work on a couple of these in class where you can see my suggestions on how you can do these a little bit easier than trying to do it with the eyeball. But so you can see how they work a little bit. What I want you to do first is we're going to rotate this figure. So you want to notice that we're rotating, so that's an important thing. We're not translating or reflecting. We're going 180 degrees about the origin. We know the origin from the past is this 0, 0 mark. 180 degrees means halfway around the circle. It doesn't have to tell us clockwise or counterclockwise, because if I go clockwise 180 and counterclockwise 180, I get to the same exact spot. So this one doesn't need to have the left or right direction, just the degrees. So what I want you to do is pause the video and plot W, X, Y, and Z with those coordinates, and then we'll come back and talk about the rotation. So that's what our trapezoid looks like at the moment. And we want to think about it turning and rotating around this shape. So again, if you have paper, I'd like you to think about how this would turn as you go. One turn and then one more turn. So the first turn is actually going to get it to go from this quadrant into this quadrant, which is the first quadrant if you remember from the past. The second turn would bring it into this quadrant. So from here, what I'm going to be doing is I'm going to be plotting my points now at 1, -2. That is my Z prime. Okay, the Y is going to come all the way around to become 4, -2. The next one is going to drop into here, and the last one's going to drop into there. So we get the same trapezoid, but I'm going to get the X prime there, the Y prime there, and we mentioned the Z prime there. So X prime, Y prime, W prime first, and then Z. We want to go in alphabetical order. So W prime is going to be at 4, -2. X prime is going to be at 3, -4. Y prime is going to be at 1, -4. And Z prime is at 1, -2. So again, the strategy we're going to talk about is to use your paper and physically turn this so you can see how that does become the other shape. It's a little bit difficult to do it right in this video, but at least if you can get these down for some ideas on how to do it, then we can talk about it from there. On the next one, more than one transformation. It's a little bit of a challenge. So you got to look at what you're doing. So I see first that we're rotating counterclockwise 90 degrees. Then we are reflecting in the y-axis. What are the coordinates? So we're doing two different things We got to make sure that we're careful about how we do each one of them. So pause the video, and it does say rotate the triangle, which it's actually not. It is a rectangle, and I know that because there are 4 vertices, not just 3, so that's a mistake. Pause the video, plot these points, and then we'll see where it goes from there. So there's our rectangle, ABCD. Now we want to rotate this 90 degrees counterclockwise. So remember, counterclockwise would be as if I took this piece of paper and I was to turn it counterclockwise 1 turn, or 90 degrees. If I was to do that, what's going to happen to this is my shape is going to flip into this region right here, and I'm going to plot those points and come right back to you in 1 sec. So there's what my rectangle now looks after 1 counterclockwise turn. And I just want you to notice that it's now standing up. So it's rotated 1 turn backwards, 90 degrees, from now going to the left. The second part of this, though, then says to reflect it in the y-axis. Now remember, the y-axis is the long one, the tall one going up and down. So I now need to shift into reflections. In the y-axis means I find the distance to that line of reflection, and then I go over on the other side. So what I'm going to do is I'm going to try to do this in red so you can see these colors. So I'm going to start with A prime. So A prime is 3 from the right hand side of the line of reflection. So I'm going to go 3 to the other side. So I want you to notice that what's happened here is A is also now the same thing as A double prime, and it's -3, -3. D prime, if I was to come backwards 1, 2, 3, 4, 5, I would then have to go forwards 5. D prime is going to be sitting right there. I'm sorry, D double prime. So D double prime is at -5, -3. If I look at B up above, it's also 3 away. So it would flip over to be here at B double prime, which is sitting at -3, 1. And C double prime is going to be sitting at -5, 1. So the image has been moved twice, and that's why these little double primes are happening, because there's the second thing that's happened to them. So it's tricky to try to do this on the video. I'm going to show you more in person how we can help ourselves, especially with that rotation. Let's move on to the next one. Lastly, we have a carousel in which we're looking at a coordinate plane kind of being made around it so that the center of the carousel is at the origin. You and 3 friends, so there's 4 of us in total, are sitting at those coordinates. So let's plot those coordinates first, and then we'll come back together. So there we are sitting, A, B, C, and D, with those coordinates. At the end of the ride, our position has rotated 270 degrees clockwise. So remember, clockwise means that we have gone this way. Okay? So we want to know what are the locations at the end of our ride. So if we start in these positions, we go this way 270 degrees. So we would go 90 degrees to this, to 180 to get here, and we're going to land over here someplace. Okay? So if you follow through with your rotations, A is going to end up at 4, -4. Which is now A prime. B is now going to be sitting at 0, -3, which is B prime. 1, -1 is C prime. And D is at 3, -1. So after a 270 degree 3-turn rotation, we have the following coordinates. A is at 4, -4. B prime is at 0, -3. C prime is at 1, negative 1, and D prime is at 3, negative 1. So this one's tricky. Rotations are always a challenge for most of us. We will try to help you with a more manual type of an idea of how to do a rotation, but do the best you can with this idea. Turn your paper. Every time you turn it, it becomes 90 degrees to the next turn, and maybe that'll help you find what the shape should look like, but we will be talking about it more in class and doing an activity to hopefully help you understand how these rotations work a little bit better. Okay, we will see you in school this week, and we'll really tackle these rotations more hands-on.